Hi everyone, and welcome back to Fundamentals of Engineering with Farhad, Structural Analysis, Brace Axial Force. In this example, we have like a wall which is subjected to a wind load of 20 pound per square feet, and two braces helps the wall in order to prevent the overturning. We want to calculate the axial force inside the brace, and the braces are 8 feet apart. So this is the 2D schematic of what you can see. That's a 16 feet wall handling a 20 pound square feet of wind blowing to the wall with the help of a 45 degrees brace. We want to know what is the force inside the brace if they are 8 feet apart from each other. So let's have the problem in 3D to observe the problem much more easier. So if this is the force, like this is now the 20 pound per feet squared, because now this is the area. Here in the problem statement we have pound over feet, but we couldn't see that area. This is the area which is 16 feet in height and 8 feet in width. The distances between two braces, because they are like 8 feet apart from each other. And as soon as we have that, we can calculate the load in 1D, like a pound per feet. So if you multiply 20 pound per feet square times the distance of the two braces, like 8 feet, you will get the linear force distributed over the unit over the entire unit width of the wall. So that's 160 pound per feet. Now we can handle the problem in a 2D environment. So now we have like our brace force like F sub B. We convert the 200 pound per square feet into a linear distribution, like a distributed load over a beam, but this is like not in a horizontal direction. It is just like a standing vertical direction, and that's 160 pound per feet. And then by applying and this is the resultant force of that distributed load, and by applying, and the amount of that is 160 times 16, it makes us the resultant. This is the F resultant due to the distributed load one. 2560 pounds and applied at 8 feet from point A. And by applying the summation of moment about A goes zero, because the problem statement says A is hinged, so there is no moment at hinge. And then we can easily say by a clockwise, which is a negative moment, 160 the FR due to distributed load times 160 times 60 is the resultant, times the distance, which is 8 feet, plus a counterclockwise moment, which is a positive one, of FB cosine of 45 degrees, times the distance, which is here 10 feet, goes zero. And the only unknown here is F sub B, or the brace inside a brace axial force. So FB is 96.31 pounds. It's almost 2,900 pounds of force for one of the brace. So as you can see here, the closest answer to all is choice A, which is 2,900. Thank you. We'll solve more problems in structural analysis. Thank you.